Hi, my name is Ellis Hiroki Butterfield, and I'm a program manager for the SQL Data Warehouse team. Today, I'd like to speak about hub and spoke architectures with Azure SQL Data Warehouse. Specifically, I'd like to talk about making your data warehousing solution more flexible and more performant to fit your needs. Now, typically when we discuss hub and spoke architectures with SQL Data Warehouse, we've often talked about Azure Analysis Services as a spoke. And while this is a great solution, today I'd like to speak about using SQL Database and Elastic Pools as your spoke. When we look at SQL Data Warehouse, we see a variety of queries by duration and frequency that hit the system. Typically, we see long-running batch analytics, and this could be any kind of long-term historical queries or ETL processes. These tend to be long, but relatively infrequent when we look at the mixed workload of a system. Next, we have our traditional BI analysis queries. And these can be any kind of queries, but they generally are in the more recent term, and they tend to focus on aggregates across a variety of slices, such as time or region. These tend to be shorter compared to long-running batch analytics, but more frequent. Next, we have reporting data, and this is any kind of canned reporting. These tend to be on a fixed rolling window, and these tend to be consistent in both time and frequency. And lastly, we have exploratory data analytical queries. And these tend to be both variable in time and frequency depending on the questions asked and the users who are asking those questions. However, we can see here that not all queries are the same. While it's imperative for your data warehousing solution that all questions are answered in a timely fashion, not all query types use the amount of resources or really benefit from the MPP architecture. The standard approach we see with managing concurrency and query performance levels is to increase the DW level. Now let's talk about a customer with the growing data warehouse. The customer starts off with a DW 400, and right now they're doing very well. They have a mixed workload of larger, longer running queries and shorter queries. Right now, there are no queries being queued on the system. The customer is doing very well. Their business is growing, and so are their data analytical needs. The customer is being data-driven, and they want even more users hitting the system. As these greater numbers of queries come in, the customer naturally increases their data warehouse level to a DW 1000. They find that the DW 1000 is meeting most of their needs. However, they've begun to notice a small number of their queries are being queued. As we discussed before, it is imperative that in a data warehousing solution, all questions are answered in a timely fashion. Now, this customer is doing very well, and to meet their growing demand for data, they've increased to a DW 2000. However, they notice that their concurrency is not increasing linearly with their increased DW level. And this makes sense, because the data warehouse architecture currently allocates more resources as you increase the scale, but to a limit, and all data warehousing solutions out there naturally have concurrency limits. Now, the customer could attempt to mitigate this by increasing the DW level more and hoping that the queries finish faster. However, at the end of the day, this is a question about resource isolation. As we discussed before, not all queries are created equal when it comes to how many resources they need and whether or not they truly benefit from the MPP system. At the end of the day, we don't want your costs to grow as fast as your business. Now let's talk about using SQL Database as a spoke. Now, as we discussed before, our customer could keep increasing the DW level. However, she's still finding that a portion of her queries are being queued. And this is because the long-running queries, which really need all of the resources, and the short-running queries, which may not use as much of the resources of the MPP system, are all sharing the same system. We find that 6% of the queries are being queued. As we discussed earlier, in a data warehousing solution, we really want all the questions to be answered in a timely fashion. Now, our customer has the option. She can keep increasing the DW level. Instead, we can think about isolating our workload in SQL Database Elastic Pools. When we do this, we find that not only has our overall system performance increased, but a smaller fraction of our queries are being queued. Or put another way, a larger fraction of our queries are being answered in that timely fashion that we come to expect. Now, these Elastic Pools can be premium, standard, premium RS, anything. And it really depends on the kind of performance levels you're expecting. Another benefit to doing this is for the same performance, especially in regards to concurrency, we find that we've reduced the cost of the system overall. Now, when we think about workload isolation in the SQL database Elastic Pools, we really want to frame it as a question of which queries are both consistent in time and frequency. Questions that really need the power of MPP should go to the data warehouse. But if you can fit the queries into this workload isolated environment, you'll find that the overall system performance will improve. Generally, this workload isolation can be anything from the schema level to different suppliers. In the demo I'd like to talk about, we're going to discuss how you can use templates to deploy a number of spokes which can read data from your data warehouse. So let's begin. Deploying SQL databases in an Elastic Pool for your spoke is all well and good. But if you're most customers, your production data warehouse will likely have many tables. Copying each and every one of those table definitions into your database spokes could be very tedious, if not downright difficult. What I'd like to talk about in this demo is a template that the team has developed in order to make this process easier for you. So right now, as you can see in my resource group, I have my logical server, hub and spoke, and my SQL data warehouse instance, WW importers. If you go look in SSMS, you can see that I have a decent number of tables, but nowhere near a production amount. Even doing this to the two spokes that I'm going to want to develop would be very difficult. Now, if we navigate to this ARM template that the team has made, all you'll have to do is fill in a couple parameters, and away you'll go. So, hub and spoke, West US, server admin, the password, the database name, and this is the DW database name, and the number of spokes I want, as I mentioned before, 2. Now, I'll need a GUID for every kind of one of these automation deployments, so I'm just going to go grab one from online. Agree to the terms and conditions, and go. So, just like a cooking show, I'm just going to show you what the final product looks like. Once you finish the deployment, you'll notice now in your resource group, you'll have 2 spoke databases, an Elastic Pool, and the runbook and automation account that was used to handle all of the metadata management. Now, let's see what that looks like in SSMS. So earlier, we showed that we had all of these tables in our data warehouse instance. To copy each of those table definitions to our spokes would have been tedious if we had many of them. Now, with the template complete, we see that not only have we developed all the spokes, but all of the external table definitions required for each of the tables in the data warehouse instance have been populated and created. A cool benefit of using SQL Database as a spoke is not only do you get all of the performance related to SQL Database as a product, but with this feature, you get remote query execution, as each of these spokes represents a user in your data warehouse. There, once the data is materialized, you can have the RLS and all of the features you require of a SQL database, but all of the security that you would expect to use in your SQL data warehouse. Now, if you've never used Elastic Query before, which is the remote query execution I'm talking about, I'll just like to show you what that looks like. So right now, I'm going to create a query from my spoke. If I were to query select top 10 from any of the tables, let's say fact sale, and run it, what I'm actually doing is I'm sending a query over to the data warehouse from the spoke and receiving the data in the spoke. Now you have not only 2 layers of security, but all of the benefits of both products. If you'd like to learn more about this setup in our architectures, please follow our blog for the follow-up series that will discuss more in depth how to implement hub and spoke architectures with not only SQL Database Elastic Pools, but Azure Analysis Services, as well as using functions to automate a large part of your data warehousing solution. If you're interested in a POC or would like to learn more about DW, feel free to contact us at aka.ms/contactsqldw. And finally, if you'd like to learn more about SQL DW, please read our docs and follow us on Twitter at AzureSQLDW.